What if right now you are swimming through a vast living world, and you can't see it, touch it, or even know it's there? What if the universe is packed with stuff that bends galaxies, sculpts cosmic structure, outweighs everything you've ever loved or feared, and it might not be dead matter at all? What if dark matter is not a thing, but a place? An ecosystem, an invisible biosphere wrapped around the stars like a second reality. You already know the first weird fact. Most of the matter in the universe is missing. When astronomers measure how fast galaxies spin, the outer stars move too quickly. By normal gravity, those galaxies should tear themselves apart. But they don't. Something is holding them together. Then there's gravitational lensing. Light from distant galaxies gets bent, as if it passed through a giant, unseen mass. When researchers map that bending, they find huge clumps of gravity where there is little or no visible matter. And then the largest scale of all, the cosmic web. Galaxies form along filaments, like beads on invisible strings, and computer simulations match what we see only if you add a cold, massive ingredient that doesn't shine. Dark matter becomes the scaffolding. Without it, the universe you know probably wouldn't have had enough time to build galaxies at all. So dark matter is real in the sense that its gravity is real. It pulls, it shapes, it dominates. But here's the uncomfortable part. We still don't know what it is. For decades, you've heard the same suspects: WIMPs, axions, sterile neutrinos, particles that barely interact. A shadow population passing through your body by the billions every second. If that's true, dark matter is everywhere, including inside the room you're in. Inside your cells, inside your eyes, the invisible universe isn't out there. It's overlapping you. Now take one more step. You know how life works in the visible universe. It doesn't need much. It needs stability, gradients, and time, energy differences to exploit, ways to store information, a medium where complexity can grow without instantly collapsing. You also know life can surprise you. On Earth, it thrives in boiling acid pools, in the deep ocean without sunlight, inside rocks. Entire ecosystems run on chemistry and heat instead of light. Life doesn't require the conditions you prefer. It requires conditions it can use. So the question becomes less ridiculous. If dark matter is most of the matter, and it has been here for 13.8 billion years, could it have its own ways to build complexity? Could there be dark structures, dark chemistry, dark predators and prey, all hidden in plain sight? At first, it sounds impossible because dark matter doesn't interact with light. But doesn't interact with light is not the same as doesn't interact with itself. And that's a real scientific possibility. There are models of self-interacting dark matter. In those ideas, dark matter particles might collide with each other, scatter, cool, form denser clumps. Not much, just enough to change the inner shape of galaxies. Astronomers have debated for years why some galaxies appear to have cores of lower density rather than sharp cusps predicted by the simplest cold dark matter simulations. Self-interaction is one proposed fix. If dark matter can interact with itself even a little, that's a door. Because interaction is how you build structure. It's how you make things instead of fog. Then there are hints that dark matter might not be a single species. The visible universe isn't one particle. It's a whole zoo. If the dark sector is also a zoo, it might have forces we don't feel. A dark electromagnetism, dark photons, dark atoms. Physicists don't assert this is true, but they explore it because nothing yet has forced dark matter to be simple. And if there are dark forces, then there could be dark complexity. Dark molecules, dark dust, dark clouds collapsing under dark pressure into dark objects. Not stars made of hot plasma, but something else. Compact bodies, clumps, maybe even dark planets drifting through halos. The more you stare at the universe, the more it starts to look like layered architecture. Ordinary matter is the bright, noisy surface layer. Dark matter is the massive, quiet foundation. And foundations can have rooms. Now the implications begin to spread. If dark matter forms halos around galaxies, then every galaxy is embedded in a vast reservoir. If dark matter can clump, those clumps could be habitats, regions with stable conditions over billions of years. If there are dark forces, there could be dark radiation, meaning dark energy flows, meaning gradients. And gradients are where complexity eats. You can imagine something like an ecology without light, not based on photosynthesis, but on transitions between states. dark particles falling into gravitational wells and releasing energy into their own sector. Dark, weather driven by dark radiation, dark currents, dark storms. If that feels too poetic, bring it back to physics. Even in the visible universe, complexity emerges from simple rules. Snowflakes, hurricanes, neural networks. None of these require intention. They require interaction plus time. And time is something the dark universe has in abundance. There's also a strange coincidence. Dark matter is about 5 times more abundant than ordinary matter. If you were a cosmic accountant, you might expect either overwhelmingly more or almost none. But it's close enough that the two components shape each other. Dark matter provides the gravitational wells, ordinary matter falls in, cools, forms stars. Your existence is tangled with the dark. So you start thinking like an investigator. If there were a dark ecosystem, how would you ever know? You would look for indirect footprints, small anomalies in gravity, unexpected distributions, heating and cooling patterns in galaxy clusters. You would look at places where dark matter seems to behave not like an ideal collisionless gas, but like something with internal life, something with viscosity, pressure, or even chemistry in the broadest sense. And there are places people have looked. Galaxy cluster collisions, like the famous bullet cluster, show ordinary matter, hot gas, slamming into ordinary matter and slowing down, while the inferred dark mass sails through with much less drag. For many researchers, that's evidence that dark matter doesn't interact much. But for others, it becomes a measuring device. It sets limits on how strongly dark matter can self-interact, not whether it can. Meanwhile, astronomers find puzzles at smaller scales. The missing satellites problem, the too-big-to-fail problem, debates over whether simulations match the number and density of dwarf galaxies around the Milky Way. Some of these tensions have been eased by better modeling of ordinary baryonic physics, supernova feedback, star formation, tidal stripping. But the fact that they existed at all invited ideas beyond the simplest dark matter picture, including, again, self-interacting dark matter, warm dark matter, or more complex dark sectors. This is where the story gets real. Physicists have actually built dark sector theories where dark matter has its own interactions and can form bound states. Researchers like Lisa Randall have explored models where a fraction of dark matter could be dissipative, meaning it can lose energy and collapse into a thinner structure, even a disk, somewhat analogous to the Milky Way's disk of stars. It wouldn't be most of the dark matter. Observations constrain that, but even a small fraction could, in principle, form rich structures. At the same time, experimentalists have been hunting for dark matter directly. Detectors like LUX, Xenon 1T, PandaX, and now LZ have pushed down the limits again and again. Underground tanks of ultrapure xenon waiting for a dark matter particle to bump a nucleus. So far, nothing definitive. The silence is loud. Then there are axion searches, like ADMX, listening for faint conversions of axions into photons in strong magnetic fields. There are collider searches at the LHC, looking for missing energy. There are astronomical searches, looking for gamma rays or positrons that might come from dark matter annihilation, with instruments like the Fermi Gamma-Ray Space Telescope. Claims appear, fade, get argued over, get constrained. So the hypothesis starts to feel both tempting and trapped. Dark matter might be complex, but it hides behind its own rules. You're trying to learn an ecosystem by watching the shadow it casts on the wall. And then, right when it feels like the invisible biosphere is about to become plausible, the twist arrives. The dominant scientific view is much colder. Most experts think dark matter, whatever it is probably simple in the ways that matter most for life. It doesn't seem to radiate, so it can't easily cool and collapse into dense, intricate structures the way ordinary matter does. Cooling is crucial because without a way to shed energy, particles don't settle into tight orbits and build complicated objects. They stay puffy, diffuse, halo-like. In our universe, electromagnetic radiation is the ultimate cooling channel. Atoms collide, emit photons, lose energy, and gradually fall into denser states. That's how you get stars, planets, chemistry, biology. If dark matter doesn't have an efficient equivalent, it may never form the stable, information-rich environments life seems to need. And there's more. Observations like the bullet cluster, along with galaxy shapes and cluster dynamics, put strong constraints on how self-interacting dark matter can be. Not zero, but limited. Too much interaction and dark matter halos would look different than they do. Also, if dark matter had a strong, dark electromagnetism and could form dark atoms in large amounts, it might create structures that would indirectly reveal themselves through gravity. More clumping, more compact objects, more distortions in ways we don't see. So the mainstream interpretation of the same facts is this: dark matter is an elusive particle species that mostly ignores itself in us. It is the quiet mass that makes galaxies possible, but it is not a second chemical universe. It's scaffolding, not civilization. But that doesn't end the mystery, because the mainstream view has its own blank spaces. We still don't know what dark matter is, not even close. The leading candidates keep getting squeezed, the parameter space shrinks. And every time a detector reports no signal, you're forced to consider that your assumptions might be wrong. Maybe the interaction is weaker. Maybe the mass is different. Maybe it's not one particle. Maybe it's not a particle at all. And even within particle dark matter, simple doesn't mean featureless. Neutrinos are simple, yet they oscillate flavors in ways that reshaped physics. Protons are simple until you open them and find quarks and gluons boiling inside. A dark sector could be mostly boring and still have pockets of richness. There's also a subtle point. Life, as you know it, requires dissipation and complexity, but you don't actually know the full space of possible life. You only know one example, built from carbon and water, running on photons and chemistry. You can't assume the only kind of ecosystem is the one that makes forests and fish. Maybe a dark ecosystem wouldn't look like organisms at all. Maybe it's more like patterns that persist, structures that reproduce through gravitational dynamics, information stored in long-lived configurations. Life, in a sense that would feel alien even to the word. Yet the skeptic in you pushes back. If dark matter barely interacts, how could anything like evolution occur? How could you have variation, selection, inheritance without rich channels for interaction and error correction? Gravity alone is slow and smooth. It makes orbits and collapses, but does it make meaning? And still, the universe keeps refusing to be simple. You live in a cosmos where most of the mass is invisible, most of the future is unknown, and most of the rules are inferred from faint signals crossing billions of years. You are a creature of one sector, trying to imagine the other. So you end where good investigations end, not with certainty, but with a sharpened question. Maybe dark matter is sterile scaffolding, the silent stage on which ordinary matter performs. Or maybe somewhere in that darkness, complexity found a different ladder to climb. Not biology, not chemistry, something else. Something that never needed light to become intricate. And if that's true, the strangest thought isn't that life might exist in the invisible universe. It's that you could spend your entire life looking at the stars, and still never notice the living world holding the galaxy together.